Hi, everyone. Good afternoon. Good morning for anyone on the West Coast. I'm going to give everyone just a few seconds to join from the waiting room before I announce today's presentation and today's presenter. I think I'm seeing people starting to join. So today's presentation is Art of Insulated Metal Panels, and we have our presenter, Dakota Jones here. He is the Business Development Manager for the Mid-Atlantic for Kingspan. So today is an AIA-approved course. So if you weren't able to drop in your AIA number before signing up today or while you were signing up, I'm going to drop a link in the chat, and that'll be the best way to ensure you get credit for today's presentation, especially since we're near the end of the year here, and we all want to get those CEUs in. Second thing to note here, the Q&A will be working at the bottom of the chat. Feel free to drop in questions there or chat me directly, and then we'll either have time at the end of today's presentation or our presenters will follow up with you after today's presentation. The last thing I want to share with you guys is how to find Kingspan on Acelab. So I'm going to share my screen real quick. So if you're looking here, this is Kingspan Insulated Panels brand page on Acelab. You'll be able to start typing it in, click manufacturers here. We'll start scrolling down. You'll be able to see David DeWolf's contact photo, as well as a great way to get directly in contact with him for any of your project needs here. And then when we scroll down, this is where you can find all of their lovely products. So if we just click on this one here, go over here, you'll be able to download everything from 3-part specs, as well as find out more about their dimensions, swatches, etc. And really important here, all their performance data. So that is everything on my end. And whenever Dakota is ready, he will lead our presentation for today.
Awesome. Thank you so much for the lovely introduction, Elise. Really appreciate it. Hello, everybody, and thank you so much for joining us virtually today. As Lisa mentioned, I'm Dakota Jones, the big, impressive name on the screen here. This is my second presentation with Ace Labs. Today, we actually have a previous one that goes over advanced features of IMPs, specifically in rain screen applications. If anybody else is learning how or wanting to learn more about how that whole process happens, we have a whole nother hour conversation about that. So again, thank you so much for having me, guys. Today we're going to be talking about the art of insulated metal panels. I am located in the business or in the mid-Atlantic region, meaning I cover from New York to Philadelphia and DC. If you guys are ever interested in contacting me, talking more about projects, want to learn a little bit more, please let me know. Otherwise, reach out to David DeWolf. He's our national director, and he can point you in the right direction. So. Without further ado, we are going to kick off the AIA portion. Well, I guess the whole presentation in general, but to start things off, we're going to go over a little bit about what Kingspan is all about. So, for those of us who are a little bit less familiar with what we've been up to for the past 60 years, Kingspan's a rather old company. Back in 1965, we started up as a manufacturer behind a family-owned pub in Kingscourt, Ireland, actually. And that's primarily where we're still based today. You can see here kind of this hotspot of clustered of businesses that we are still primarily a European-based company, but growing like a weed domestically. Since that rather rural beginning, kind of humble start, we've managed to grow to be a global occupation now. We're the largest IMP specified manufacturer in the world. We occupy over 80 different countries. We have 212 manufacturing plants, multi-billion dollars in revenue back in 2023, and a whopping 22,000 employees worldwide. And I will say a good portion of those are nerds like me with advanced degrees foaming at the mouth to help you guys with really complex projects. We go to bed early for that kind of stuff. So please take advantage of our time. We're always, always, always happy to help. Now, I would be remiss if I didn't mention the other hats that Kingspan wears. You don't get to be, the size we are without adopting some more companies with kind of a like-minded ethos to yourself. So maybe you have heard of Kingspan insulated metal panels. Maybe you haven't. If you haven't, maybe you've heard of our other divisions like Kingspan Light and Air, which does polycarbonate panels, makes your building glow. Really cool stuff there. We also own Morin and Dry Design, which does some of our higher design exposed natural metals, Corten, patinaing stuff, that kind of thing. Also, we own a strictly insulation division. Kingspan Insulation with their recent product Optimar, which does crazy R value numbers. They have a vacuum panel that you can put on the roof. It's insane. I'll let them talk about that, but that's very impressive technology as well. And then if anyone is working in the data center space, make sure that you check out Tate as well. They do accessible floors, they do the racks, they do all that stuff. They're like one-stop shop for data centers. So The reason we've kind of aligned ourselves with these particular companies that we've acquired over the years is because Kingspan has had a long-going mission of giving you guys, the designers, the construction managers, the architects of the world, the tools you need to make really cool net zero buildings. That's going to be kind of a reoccurring theme throughout this presentation. So the eagle-eyed among you with this small text can see that a lot of these products that we're promoting and own and align ourselves with are either upcycling or recycling material into their content, meaning that we are lowering the amount of embodied carbon that's actually going into our products before they even show up to your guys' job site. And this makes us incredibly competitive with some of the biggest companies in the world, and we think it could make you guys competitive as well. So whether it's the photovoltaics division or the insulation or insulated metal panels, which is primarily what we're going to be talking about today, just know that we're really supporting that initiative. About 15 or 20 years ago, we really put our money where our mouth is, started seeing the writing on the wall about how our industry was affecting the environment, and we launched our Planet Passionate initiative. And this, I tell you what, is what gets our foot in the door with some of the biggest companies in the world and keeps our foot in the door with some of those big companies. Because even though you have to kind of bend your arm a little bit to kind of remind them of their sustainability goals, ultimately, when we're at the table, we tend to stay there because, again, we're so competitive. We've been leading the industry in both innovation and sustainability for so long. Now, the reason this has resonated with so many big companies around the globe is because of fears that the industry has long had for a very long time about our impact. And for those of you who don't know, the built environment, unfortunately, is a very dirty industry to be in terms of like greenhouse gas emissions and things like that. Back in 2020, these suspicions, these kind of weird feelings we had in our guts were later validated by the USGBC, the United States Green Building Council. Back in 2020, they found that about 33% of all global energy is consumed by the built environment. It's a lot of energy that we're taking up to maintain what we have and expand what we're wanting to build. Additionally, about 40% of all greenhouse gas emissions, making us one of the largest contributors of those as well, also produced by the designers, the architects, the engineers, the manufacturers, uh, putting that pollution into the air, unfortunately. Now, despite these numbers being so high, only about 3% of our current building stock is considered efficient globally by today's standards. And this number is a little bit debated, primarily the IBC updates every 3 years. And to my knowledge, it's never gotten any more lenient as far as energy performance is concerned. And so whether it is actually 97%, we don't know as soon as that 3 years passes and we've met our legal minimum required for energy efficiency. The next year it updates, all of a sudden it's out of spec. So you can debate that number a little bit, but the final kind of twist of the knife is right here. 11% of embodied carbon on the planet is sitting in these building materials of these buildings that are unfortunately not even serving us that well. And so this is why adaptive reuse is so important because this stuff that should be sitting in trees and peat bog and permafrost up in Russia and Alaska and stuff is actually sitting in the brick and the stone and the glass of these buildings that are unfortunately underserving us. We want to make sure we're doing things like adaptive reuse as well as, really taking care of these buildings as we move forward. So the one thing we are certain of, or at least the USGBC is certain of, is that we need to grow, right? About 2x the global floor area of the built environment, which is by 2050, which is the equivalent of adding the entire city of Paris to the planet for the next week, for the next 25 years, every week for the next 25 years. It's about 1,300 Parises. It's a lot of carbon. It's going to require a lot of energy, about 50% increase in energy demand. Now, I don't think that they were anticipating the AI race, unfortunately. I do think that's kind of a gross underestimation at this point, but it's a challenge that we're facing. And us being architects and designers and all these creative people, I know that we can meet this challenge. And so, again, Kingspan's trying to lead that charge as well. How we're doing that, we set some kind of northern stars that we could measure our own sustainability success on. And these are illustrated here: energy, carbon, circularity, and water. Specifically with energy and carbon, this stuff is pretty intuitive to what you guys would expect from a big manufacturer. If we own these large 300,000 square foot manufacturing plants, why wouldn't we take advantage of all that flat area and add things like photovoltaics on the roof, solar cells, solar panels, that kind of stuff, produce our own energy, harvest our own water to make sure that we're actually using that in our manufacturing process? Why wouldn't we pursue lowering our emissions by electrifying our fleet? Kingspan takes that very seriously, from the company cars we come to visit clients with to the forklifts on the manufacturing floor, all using renewable energy, all using electrification. So The thing that really makes us shine, though, is that circularity, this piece right here. This is promoting a circular economy as far as materials are concerned. So when we think about materials, we make a plastic bottle. We get one use out of that. Do we recycle it and get another use out of that bottle? Or does it go into a landfill and degrade over time? Unfortunately, only about 9% of building materials are recycled nowadays. So Kingspan's committing itself to being a zero company waste to landfill. And recently, up in Caledon, Canada, actually, we just had our first industry manufacturing plant celebrate their first year of no waste. So it's pretty fantastic. And on top of that, we actually have a take back program. So at the end of the insulated metal panel's life, this is essentially steel insulation foam and then steel. So it's a sandwich. We could take that insulation on the inside when we take these panels back after the building has been decommissioned, mulch that up, and then essentially use it as aggregate for concrete, and then it makes it lighter weight, more insulative, and then the steel's recycled as well, meaning that that product gets another chance at life, which is really, really cool and allows us to give you guys opportunities to pursue LEED credits and wellness credits through environmental product declarations, EPDs, or life cycle assessments, LCAs. Finally, water. This is a global organization, Acelab is. So here in the West, out in America, we don't talk about water too much, unless, of course, something's getting flooded or California's on fire for the 17th time that year. But Kingspan's certainly aware of it and wants to get ahead of that by participating in ocean cleanups as well as harvesting water and doing everything we can to make sure we're getting ahead of that curve. Now, the reason we're kind of promoting the sustainability stuff right off the bat, I'm sure you're like, oh, I came here to learn about IMPs, right? Well, we do almost, I don't want to say have a fiduciary responsibility to do so, but we care about this stuff incredibly much. Like we find that it leads to a lot of success. I've mentioned a few times now that we are a European-based company, and that means a few things. It means in order for our stakeholders to have confidence in our ability over in Europe, we have to show that we're making meaningful steps toward achieving these sustainability goals. And so, keeping that in mind, we have every reason to continue down this path. And even if none of this stuff is resonating with you, just know it's how we do business. It's happening in the background. You're not paying for some greenwash premium of some upcharged price for some greenwash product. It's nothing like that. We are still incredibly cost competitive. We just care about this stuff. And again, it makes us competitive, and we think it makes you guys competitive. So if you're wondering why we're hitting you over the head with the sustainability stuff right off the bat, just know most people don't care about what you know until they know about how much you care. I hope we've illustrated pretty clearly. Kingspan cares about this stuff quite a bit. And me in particular, I'm kind of a big hippie when it comes to this stuff. So, if you guys have any questions about that, like Elise mentioned at the top, please drop me your questions down below. Happy to address those. Otherwise, we're going to transition into some non-proprietary speak about Kingspan, away from the dog and pony show and into the AIA credits. And so I can't talk about Kingspan anymore because I don't want to go to AIA jail. I'm in the process of taking my architecture exams, and I don't want to lose my ability to acquire that license before I even get started. So. With that being said, we're going to be on our best behavior. Everyone's going to be receiving credits for this presentation. Should be here for about a tight 50 minutes. It's very, uh, luckily, pretty presentation today. We're going to be going over a lot of photos, case studies about what IMPs can do. But, I'm just talking. Let's just get into this, right? Introduction. Let's talk about what we're going to be speaking about today. So to set the stage for the discussion, and honestly, to help you guys retain some of the information of what we'll be talking about today, I want to start by asking kind of which camp all of you fall into and which you identify with. In architecture, we often find, in terms of form over function or kind of function over form, we fall into those, right? Most of us live somewhere in between those two extremes, but naturally we lean toward one side or the other. Insulated metal panels, IMPs, which is an acronym. I'm going to abuse this whole presentation. Just know I mean insulated metal panels when I say IMPs. Really do a good job of supporting your design intent no matter which category you fall on that spectrum. They can deliver performance, high efficiency wall systems, even behind a system that's not an exposed metal building. But alternatively, they can also be the face of the building, offering exceptional performance while effectively communicating your design intent through exposed metal facade systems. So think of the aesthetics of a similar extruded panel plank system, like plate or aluminum composite material, ACM. These looks can be achieved by IMPs as well. And so challenge yourself to think about where these panels can be a good fit. As we dive deeper, just consider the projects that you're already using these types of materials on and reflect on whether or not IMPs can support that design intent, either as a functional backbone or as the entire building envelope with that primary form being communicated by IMPs as your building skin. So, if this is your first time hearing about IMPs, you're in the right place. Okay, today's session is going to be a strong focus on the fundamentals of understanding how these systems work, and then we're going to look at see how they can actually what they can achieve and how other peoples have successfully used them in the past. So again, no matter what camp you fall into, the system's got you in mind. We're here to support you, no matter what your design intent is. So getting into learning objectives, right? If I do my job correctly today, we're all going to walk out of this session knowing how to have a solid understanding on these several key points. Okay, first, we're going to be talking about how we can use IMPs to enclose a structure safely to keep occupants healthy and comfortable on the inside. We're then going to be talking about exteriors of buildings, thinking about how we can actually use shape, pattern, forms, kind of that form over function look, textures to satisfy this type of look that we're going for. After that, we're going to be talking about, once we have those foundational kind of building stones set, we're going to be transitioning into how we specify these materials and how we can look out for different things and details so that we can be more specific on what we need to call out in our drawings to make sure everything is going as we intended. After that, we are going to wrap everything up nice and cleanly with my favorite part of the presentation, which is digging into the details of IMPs. I'm definitely a function over form guy. I was definitely the detail guy back when I did architecture, so we'll be getting a little bit into the nitty-gritty with some wall details and stuff. So save your questions till the end there because we have a lot to go over. So, learning objective number one, how can we achieve the form we envision while still meeting the required function? In other words, how can we deliver full performance out of an IMP when using non-IMP exterior finishes? How can we keep everything safe on the inside no matter what look we're going for? So let's talk about how we can do this. Let's start way back, okay? Way back when Kingspan started. I know we started in 65, but let's kick it to the 1970s, okay? Like many great building products waiting for their moment to shine, insulated metal panels found their footing in the late 1970s. Fuel prices were surging. Industrial building owners, manufacturers, those who were often facing having to heat incredibly large uninsulated warehouses began facing dramatically rising energy costs, okay? That's the setting that we're stuck in. To keep operations efficient and to meet growing demand, they needed a solution that still performed very well as far as thermal performance. Well, I guess they needed a new product that could perform better thermal performance and could still be installed quickly, span long distances, and remain incredibly cost effective. This is where IMPs found their footings and they were finally recognized for the value that they brought and began to be rapidly used over an expanding industrial and commercial age during that time. By the 1990s, though, IMPs had gone completely undergone their transition into becoming the go-to building envelope system across a wide range of occupancies, aesthetics, all different types of applications. And today, IMP technologies have evolved so much that modern systems can compete with some of the highest performing envelopes in the world, delivering something like R7 to R8 on average per inch of insulation values, exceptional air tightness, and a level of versatility that supports both performance-driven and design-driven architecture. Now, once we understand, and now that we kind of understand how IMPs got their start, we can look into their competition, which is the built-up wall system. And this has essentially been the status quo over the past like 30 or so years. Now, built-up wall systems are something that we probably all know, probably all love. We definitely specify them quite often. And I'm never going to argue against built-up wall solutions. They have their place in the market. And as far as competitions with IMPs, unfortunately, there are a few flaws we have to recognize that become apparent when we start analyzing these with a microscope, right? Where IMPs can be mounted directly to studs and work in every single climate zone, pretty often with long spans, using steel systems, things like that, not having to rely on ma many fasteners, not having to deal with thermal bridgings, uh, to be concerned with. Multi-component systems, by contrast, unfortunately have a few built-in Achilles heels. So even if they're assembled perfectly, unfortunately, due to their complexity, we're often relying on a lot of different systems to work and do separate things in order for it to work together. So with a built-up system, we're relying on the sheathing and the air barrier and the insulation and the Z-girts all working incongruently to make this thing perform as intended. With those Z-girts specifically, that offers a pretty strict thermal bridge through that envelope system, and energy often is going to take the path of least resistance. And so even if everything is done perfectly, it's an incredibly complex system with long lead times, long construction times, and when you contrast that with IMPs, which is one trip around the building to get stuff done, we're often installing 50% quicker and unfortunately performing better on a performance level when you compare the two. Again, they both have their place, but there are some pretty serious drawbacks to consider. IMPs also have drawbacks, and we'll certainly talk about that as well. I'm sure you're probably thinking, after me kind of beating down on multi-component systems, how can a single component system like IMPs possibly do everything a built-up wall system can do? So let's talk about that. Insulated metal panels function as what you guys might have heard of as a barrier wall system, meaning it's impermeable. Uh, this basically allows no air, vapor, moisture to pass through that system at all. Think of a non-porous material like glass or steel. They perform well on facades because they don't absorb moisture, but the difference is that with glass and steel on their own, they kind of lack that thermal performance needed to act in a high efficiency manner, especially along the whole building envelope. They're good for some of the translucent surfaces, but we can do better on the opaque. By contrast, IMPs have that high density insulation sandwiched in between those two sheets of metal, one in the front and one in the back, and that offers great thermal performance to defend against thermal loads entering the building, meaning that despite the system being attached directly to studs, essentially the air, water, vapor, and thermal control in all is on the exterior of that envelope and never even has to touch the inside of that building. So again, with you consider how quick these things go together and they snap on top of each other, kind of like Legos, we can get the entire building buttoned up 50% quicker. And we don't have to worry about specifying each individual piece of that built-up multi-component wall system. And often, unfortunately, we do get better performance because of it. So both have their place, but it's kind of at your discretion to figure out which one's best. The value of IMPs. Ultimately, um, if it helps you think of IMPs in this way, think of them more as like a rigid insulation board. It's exceptionally effective at controlling the transfer of thermal energy because of that insulation on the outside of that structural system. This eliminates the potential for thermal bridging and it dramatically reduces that compared to traditional wall systems for all the reasons we just talked about. Because those Z-girts are conductive, unfortunately, they can let that backup wall get cold enough to where condensation can actually occur. So on the right side of the frame, you can actually see where IMPs are being attached directly to the structure, and you can actually have that exposed insulated metal panel look. So you don't necessarily need to finish these products, but you certainly can if that's the aesthetic that you're going for. In this particular application, this is cold storage, meaning that that R value, because it's in a colder solution, actually jumps up to R9. We'll talk about that in a little bit as well. But this is completely appropriate. It can be exposed, and due to the redundant nature of that steel insulation steel, we can riddle that exterior face with holes and never have to worry about compromising the weather tightness because that steel is in the background. It's kind of a double barrier system. Pretty neat. Now, as I mentioned earlier, most IMP manufacturers are using some kind of closed cell insulation. Typically, this is a polyisocyanurate. We refer to it as PIR because nobody wants to say polyisocyanurate all the time. Depending on the panel thickness, PIR can deliver R values ranging from roughly R5 to R64 with a maximum panel thickness of about 8 inches. So even the most complex point of the IMP we can see in these comparison here, which would be the joint, there where two panels meet, the thermal performance remains dramatically better than the typical range screen assembly. That's primarily because of the fasteners that need to pass through that insulation on that multi-component system. With the insulation on the inside sandwiched between those two steel sheets in the IMP solution, we can see much more consistent thermal performance, meaning that that backup wall, again, doesn't have as much opportunity to get cold enough for condensation to occur. This eliminates the risk of mold, mildew, grandma's basement smell, structural damage, that kind of stuff. Whereas with here, we have those Z-girts, again, often conductive materials, and that just allows a much deeper temperature discrepancy between those two systems, meaning that this backup wall could potentially get cold enough to allow condensation to occur. We super don't want that. Now, of course, in situations where metal facade isn't exactly the aesthetic that you're going for, we mentioned this, IMPs still have your back. They still can have you covered because IMPs can and often are used as a backup wall solution. I mentioned we have a whole nother presentation about that specifically. You can retain all the performance benefits of a standard IMP installation while still supporting a wide range of rain screen aesthetics on your exterior. This means that you can still wrap the entire building in a unified high performance envelope, often 50% quicker, again, compared to a multi-component system, while applying whatever cladding system you want, as long as we're adhering to things like fire code and, of course, your design intent. Now, facade types. This means that we can offer quite a bit of design options out of an IMP envelope, either with IMPs being exposed or without. So let's kind of dig into some case studies and talk about some examples of what things we can achieve with this and what others have been successful with in the past. Just to kind of whet our palate into what we're going to be talking about, here's some highlights of some heights that IMPs have achieved in the past. Some of these we'll talk about in depth, others we'll leave to have you guys kind of experiment and think about on your own terms so that you guys can do a little bit more investigation to see what fits you. But this will kick us into learning objective number two. How can we use our new IMP tool that we just learned about in our toolbox to communicate interesting forms, shapes, patterns, textures, designs, all this stuff, right? Let's see what people have been successful with in the past. Starting off with dimension, line, shape, and form. Like any tool in your toolbox, let's be real, okay? Each approach to putting metal on a building comes with its own advantages and disadvantages. We're not here just to beat down on multi-component systems. Let's get into it. So, when we talk about communicating your design intent using metal on a facade, there are countless aesthetic and performance options, but ultimately these fall into four main categories. The first is aluminum composite material. These are panels that you've often seen on the exterior of virtually every car dealership you've ever driven past in your entire life. They offer really clean lines, sharp geometries, premium appearances. They're great. People know them, people love them. Single skin, second flavor. Think of corrugated or ribbed metal profiles, commonly used in like industrial or utilitarian buildings. They're often lightweight, cost effective, very versatile, and people love perforating them. Plate is kind of the third one. It's still an ACM look, but this is a non-combustible variant. It's essentially thicker. The reason we want it thicker is that we can still achieve nice, fun geometries, but we can also really get some good performance out of longer spans because it's a thicker metal, meaning it doesn't oil can. So oil canning is when that phenomenon happens of that metal getting hot, getting wavy. We don't like that, so sometimes we use plate. Insulated metal panels are the final flavor that we're going to be talking about. As we move kind of from the back of napkin sketch toward the final construction documents, understanding these four flavors of metal helps us align our initial design intent, budget, performance, and constructability. For example, let's look at the photos that we're looking at here. This building that we have detailed, you can see an exposed metal system. I wouldn't blame you if you're like, that's an ACM application. Look at it. I'm sure you would be surprised, or maybe not surprised, because this is an IMP presentation to learn. Those are exposed IMP systems. We have painted panels, of course, and we have a really nice sheened panel, maybe a glazed or really polished stainless steel, right? Working collectively to still bring that nice facade in to play. So a great way of using IMPs to design and communicate that design intent. So here again, depending on the light, you can use not only materials that you're specifying, but also finishes to capture more visual interest using that shine versus that matte finish. Obviously, the intent here and coordination was put in quite a bit early on in the design phase. So we need to make sure that we're getting that premium look in this particular case. And we are honestly, this is why we have these sessions, right? Like, how do we achieve that kind of a look? It takes coordination ahead of time, and we want to have that conversation early on to make sure that we're executing at the level that we're hoping to achieve. This is an example of, let's talk about some of the considerations with different metal facade types. We talked about ECM, we talked about plate. Each metal facade system comes with its own considerations, and we definitely need to keep those things in mind. We already talked about ECM, the benefits of that, and plate and single skin and stuff, but these have some challenges, right? With ACM, there's going to be some introduction to some fire code challenges depending on the project, depending on the location. With plate systems, they're going to have some geometry limitations due to their rigidity and their material, which is what we want, but also can lead to some limitations. Additionally, with single skin, this can come with some aesthetic limitations. A lot of people don't want corrugated metal in certain areas, so we have to adhere to that. With IMPs, the thing that makes them great is that they are a single component system. That's great, right? But when we think about something like this, a really high design staggered joint approach, this is our Achilles heel, right? In a situation like this where we're going to have unaligned joint lines and things like that, this is going to produce situations where there can be some guttering, some shoulders where water can sit. And if it sits too long, we can have issues later on down the line. So if we are doing a really complex geometry, if we have skyward facing panels, IMPs are going to need that backup wall. Not an entire backup wall, some additional sheathing, some dense glass or something like that, in order to make sure that the wall is going to again perform as intended. So that's our one drawback, of course, is that if we're getting too crazy, we do have to add an additional sheet of layer. That's the sacrifice we have to make for good design. But again, you're still going to get that install speed that you're looking for, because then we're only 2 trips around the building. So there you go. But you still can achieve some great looking facades. Now, if we're looking for a solution that's going to be using two different types of approaches to achieve, let's say, the first flavor of metal that we talked about with the ACM exterior, right? IMPs can also still serve as that backup wall. This is a situation where we have a facade that wants to be a little bit more three-dimensional than IMPs are willing to achieve. We can still take advantage of all the benefits of IMPs and support this system as intended from that structure to make sure that it still looks the way we want it to look while having the performance of IMP in the backup, because IMPs can't necessarily achieve this type of look. It would be very hard to manufacture. An example of color and how we can use color. Now, I'm sure everyone would be so surprised to learn that hot pink is not necessarily in the Rolodex of standard colors for most IMP manufacturers, but I'm sure many of you are also not surprised that many manufacturers of IMPs also provide custom colors to match whatever you guys are looking for, whether it's proprietary or otherwise. Just know that that's an option for you. Takes a little bit more forward coordination. We talked about that. If you're going for premium looks or colors or finishes like that, it just takes a few extra steps to make sure that you're getting exactly what you want. But you want to think about that, especially if you're going for something as cool as this, sitting down in Miami with that hot pink. Love that project. There we go. Of course, this is another great example, another hybrid approach of using different metal layers, but patterning and layering different metal finishes as well, right? While performance is always a key consideration, especially on larger buildings that need to keep the outside out and the inside in, we can still get creative. By leveraging our full toolbox of metal facade products, we can layer applications in ways that adds intentionality and three-dimensionality, create a lot of visual interest on projects while still using all the arrows that we have in our quiver. And this is an example of just that, where maybe we have some plate, maybe we have some ACM, maybe we have some IMPs in the back, and maybe that perforates and offers kind of a shade screen toward the front. It really gets the design juices flowing. This is an example of some contrast that we can use, a fun little project where we can see, some kind of anchoring being communicated at the base. It's very visually interesting, keeps everything at eye level, to kind of maintain a base and a foundation, but then you juxtapose that by introducing a different texture, a different color with the massing where the actual function of the building or the campus takes place. So, whether or not you think this design approach is successful is up to you, but just know that again, these possibilities are achievable. Using things beyond color and pattern, contrast, things like that. We can also see variance in facades using textures and communicating things via hierarchy, eliminating different elements and making different elements larger in order to communicate something like a cave opening, establishing where that entrance is going to be, and of course, still giving some visual interest with material changes as we wrap the building. This building could be very boring if it was all white and it was not textured, but because we've added some different anchor points, added an entrance, added some variation in vertical circulation areas, that actually does a really good job of communicating not only the function, but the intent of what's happening on the inside of that building. Very, very nice creative approach. This is another example of IMPs doing the work behind the system. This, I don't even know what this is, but like let's just say IMPs would have a very hard time achieving this type of a look. This is a very premium look, as I'm sure you can imagine. But again, we can still be there to be the nice backup wall, supporting whatever your design intent is and offering a nice framing for this beautiful curtain wall system that's being introduced into this very modern facade. And of course, it's in Quebec. Yeah, great looking project. Wow, I should look into that one. Here we can observe not only the difference in colors, but also in gloss and finish, right? So notice how your eye perceives color differently, comparing the matte finish to a satin or glossier finish, right? With some projects, we have plenty of examples of them specifying one black color and then changing the finish of that color. And at different times of day, it looks like you're using several different colors, when really it's one color, just different levels of finish. So another great little approach to that. Of course, when we talk about custom colors, examples of matching existing conditions, just know that that's an option too. When we talk about promoting adaptive reuse, renewing buildings that otherwise would be demolished to be reestablished, we want to make sure that we're taking advantage of that carbon that already exists, affecting that 97% ineffective number that we talked about at the beginning. We can reduce that by color matching, matching what's already there and changing it for the better, making it cooler. So here we have a situation where we have two different project products playing together, but of course the colors, two different uh, products rather, interacting with each other. But the colors are all premium, they all match, they're all good, no matter if it's IMP transitioning into ACM. Again, a little bit more coordination, but it should be just fine. Another thing, this is the last we'll talk about with color and things like that. But a question I get myself often, and I'm sure other reps get this question pretty often, is uh, IMPs are steel, right? Can we swap it out for anodized aluminum or Core 10 or something like that? The short answer, unfortunately, is no. Testing is very strict with what most IMP manufacturers can use, and so primarily we're stuck with steel for most of them. But do your own research, of course. But just know again that you have other tools in your quiver from all the other methods we talked about with getting metal on a building. Here we can see an example of a really nice shiny extruded plank. Maybe it's a copperish finish or an anodized aluminum. So in this case, this would be a good application where IMPs can still serve as the backbone of that project, but your design intent can still be communicated in front. It can still be shown as that nice shiny metal that we're looking for. So if you're going with polished stainless steel, that's one choice. Otherwise, if you're going with a nice shiny extruded plank, just know that that's also another option you can choose. We'll support you either way. Of course, transitioning into texture. Again, not every building wants to be some variation of metal. IMP manufacturers know very well that not every building wants to look like a distribution center or anything like that. So leveraging that technology as being the backup wall allows us to come up with some creative solutions to some really complex problems. And so we can still get the performance and still get the look that we're going for. This is an example of just that. You'll see down here, this is a LEED Platinum accredited building and one that you would walk by and be like, oh, there is no way that is IMPs. Let me tell you, my friends, ye of little faith, that is an IMP building, a backup wall system with a fountain in the middle, believe it or not. 2030 Challenge project, incredibly comfortable. I had the chance to actually see this in person. It's a great building, and you'd read it and you'd be like, oh, maybe there's some metal here at the base, but primarily it's that brick facade all the way, even up to here, is a massive project. And again, it's still brick. It acts like brick. It is brick on the exterior, but that backup wall, that performance that we're looking for is primarily that IMP doing all the work in the back. Another aspect people often overlook with IMPs is their ability to curve. This example shows exactly that. As we wrap that facade with what is probably like a 3-inch panel, you can kind of seamlessly transition to a rain screen panel, meaning that we can change out those materials as we go from metal to wood or extruded plank or IMPs as we curve. Again, many tools in our quiver that we can take advantage of. Of course, if we're going for more of a niche look, I know concrete's always a big fan for architects and designers around the world. Just know that we can also achieve that look as well. Many manufacturers can kind of give you that stucco finish, that kind of nice coarse texture that you want, still be an exposed system. This is an exposed IMP system, but as you would get closer, you'd be hard pressed to say, hey, that's not ephes, hey, that's not some kind of stucco, something like that, or a concrete. You can still get that look, still get that performance with an IMP. Then, of course, this one's just kind of showing off, honestly. I mean, we can still create a lot of eye movement with a higher design. Obviously, this project is within the same color palette. We're working only with whites. As far as the color is concerned on these panels, communicating some horizontal lines, but as we shift our eye up, we change that texture. We go to a rain screen, and then we do this kind of perforated, corrugated single skin, and it moves us up toward the penthouse. You see how our eye travels across this building. So again, just knowing that those are options and these are things that we can support you in is very important. Another great example of a project that wanted more than IMPs honestly could offer. Don't feel limited by the IMP industry, right? Just know that you can still have that performance and you can get everything you need out of a rain screen, but still get that construction speed, still get that performance. And you're not worried about things like UV degradation as these panels are exposed because it's steel. It's not going to go anywhere if the sun hits on it. It's really not a big deal. And then if your facade system is late to the job or something like that, you can install it at a later date. It's still just fine. It's still just good to go. Oop, I miss. There we go. Learning objective number three, specifying IMPs. This is some of the nitty-gritty stuff that we need to keep our eye on if we want to make sure that we're specifying this correctly and that it's going to come out as intended. So, the main two things we want to keep our mind on when we're talking about specifying IMPs primarily is going to be the thickness and the insulation type. What's on the market today is primarily polyisocyanurate, which we mentioned before, the PIR. Nobody wants to say polyisocyanurate. It's a closed cell insulation foam, often high density, ranges between R8 to like R5 in some cases. And often that's determined, this is going to be determining what your panel thickness is going to be. It's also important to note that depending on what your fire performance wants to be, if you're hoping to achieve a particular wall, whether it's fire rated or something like that, you can actually swap this core out for mineral fiber, meaning that all the RMP manufacturers can get you up to like a 3 hour wall with like an 8-inch panel because that becomes a non-combustible material. So there you go. Now, once the thickness and the insulation is established, we can then move into selecting colors, finishes. Even what appears to be a flat insulated panel can often be profiled to add subtle texture. This helps prevent a phenomenon that we call oil canning. Again, we talked about how it can get kind of ripply, right? If that panel gets too hot, it can become delaminated or something like that, and it can get wavy. We super don't want that. And so what we can do is add things like mini micro ribs or embossing or texture again to break it up a little bit. And at higher elevations, you wouldn't even be able to see that it is actually textured. But just know that these are things that are going to be asked of you when you are specifying IMPs. What kind of finish, what kind of profile do you want? Do you want a true flat that's going to be susceptible to that heat gain, or do you want something a little bit more textured, a little bit more ribbed, something that's going to offer a little bit of shadow and dynamics toward the end of the day as shadows are cast onto that building? Also, manufacturers can often distinguish between the interior and exterior finishes of a panel. Often the interior is, that interior steel is going to be your exposed shadow line, often white because you're going to cover it with chipboard anyway. But if you're looking for something specific and you want to have it exposed, like we saw in that cold storage situation earlier on, you can do that. You can have it painted, you can have it colored, whatever you want. That exterior profile, though, that's where we're going to get into the weeds, right? That's where we're selecting color. The gauge of the metal itself, that range is typically between 20 to 24 gauge. Whether or not you want that really beefy or really soft is up to you. And then, of course, as we transition into color detailing options, just know all IMP manufacturers have a plethora of different colors that you can choose from, whether it's custom or whether it's standard. There's so many finishes to consider. There's prints, there's coatings. Like if you don't want paint, you can do a print. There's coastal finishes, stone, iridescent finishes, chameleon colors, kind of like what's shown here, where it's going to change color as you walk away from the building or walk toward the building. It just depends on what your program is. Again, takes a little bit more coordination at the front, but you can get it done. Drawing more from our toolbox of IMPs, we know that we have different profiles available, so we can actually use that to communicate elements of the building. But as we see through our case studies, and as we're going to see, we can use texture, whether it's flat or corrugated to again give some more visual interest. If we're going to be looking at a big, large blank wall, why wouldn't we break that up with a little bit of a louvered looking system or something like that to give it a little bit more character, give it a little bit more something that's going on. Nobody wants to erect a giant white wall that's going to drive everybody crazy as they walk past it every day. So let's have a little fun with that. Connect it as we go up so that we can still keep that nice thermal continuity in terms of enclosure, but still a really dynamic facade, even with an exposed system. Again, we talked about curved panels. We'll have a few case studies that we'll talk about with this in particular, but just to, again, get your design gears turning, note that IMPs can be curved, whether it's horizontally, vertically, concavely, convexly. We can get it done. If you're looking for something really crazy, if you're a big fan of Zaha Hadid, shoot us an email. Maybe not Zaha. She's a little out there, but we can get some fun stuff done. Uh, as for the curves themselves, we know that we can achieve those, but we can get up to column wraps, right? It's a very creative way to kind of communicate a corner, soften a corner if you do want to wrap that edge as opposed to doing something a little bit more harsh, which is expected with larger commercial buildings. Otherwise, I mean, these can be wrapped up to a foot. So if you want interior or exterior applications where that column still wants to be insulated, that's also an option. As far as edges are concerned, when we think about metal, especially when it meets at a corner, we often think about trim, how that's going to look. Just know with IMPs in particular, we could take advantage of the dual nature of that steel insulation steel sandwich, right? And we can essentially miter that inside face. We have a detail of this in the next one. Can miter that inside face so that we're not disrupting this exterior steel face. And we can wrap that corner while still getting that nice insulation on insulation contact and dealing with the corner that way. We will have to adjust our legs of our IMP, essentially the length that wraps around that corner, to where it makes sense. We can tie into another IMP if we don't want to joint. Otherwise, we could see some trim there. But essentially, we can solve a corner without ever having to worry about trim or extrusion or something like that. So again, people overlook this, but just know that technology already exists. We can do that. Again, when we're talking about not again. We've been talking about a panelized system. IMPs are panels. They span great lengths for sure, up to like 53 feet. But in most cases, we are going to be dealing with sight lines, right? These joints have joinery, and that is going to lead the eye to different parts of the building as we kind of create this checkerboard effect. Just know that again, we can be very intentional with those, lining them up with mullions and things like that in different aspects of the building, as well as highlighting them and expanding them in order to make sure that we can introduce things like joineries and ribbons across our building, eyebrow soffits, so that we can make sure that we're getting that look that we're going for and drawing eyes where it makes sense. If we want to make these lines a little bit more quiet and make these lines a little bit more loud or vice versa, we have tools to do that as well. Just depends on what your design intent is. We're here to support that. Of course, with modified edges, we are talking about a particular panel today that has systems where it's going to be exposed, kind of a premium looking finish. Just know that the steel, if you're wondering about how that joinery connection happens in a horizontal application where the IMPs are not clicking together through that joint, kind of like what's being shown here. Another IMP is ready to be stacked up here, but what happens at this? We have that nice flat surface. What's going on? Well, what we've done is we've wrapped that corner with that steel, and then we've added this pressure-fitted rubber gasket so that we have this nice black line. Now, unfortunately, there's some drawbacks to this. Obviously, we have a big thermal bridge, right? We have rubber and then structure. Not great. Alternatively, if we're worried about energy performance, we can go with something closer to this. This is a block spline detail where we have that insulated layer blocking that structure and we still get that exposed surface. But just know this is an effective way of dealing with this condition. Many people still use it. It's still great. It's just a little bit more economical. Just be aware of that. Learning objective number 4, detailing IMPs, looking into how these things actually go together. This can get complex. I'm sure this is where most of the questions will come up. So make sure to ask those questions now. Otherwise, hopefully, it's pretty self-explanatory. Like I said, they're basically just big old Lego kits. One of the leading questions I get, how does IMPs interact with the roof? Well, I am so glad you asked because let's talk about it, right? This is the parapet condition. This is when our panels have exceeded their usefulness and we're reaching the roof. We need to wrap that corner. How do we do that? Obviously, we're still worried about weather tightness. So what we're going to do is lap this exterior membrane of that roof up and over that parapet and then back around the face of that. Obviously, we have our little insulated cap here and a little lip so that water can run down that face and we have no negative lips or anything like that. So we still have that nice insulation continuity. And then, of course, we're not worried about water pooling or having anywhere to sink in because we're wrapping and capping that particular edge. On a flat roof, if we're doing something like monopoly framing, it's very similar. We want to avoid negative laps. If those of you were unfamiliar with what that is, essentially it would be if the piece of sheathing or something like that were facing skyward and it were open, essentially creating a little cup that water could connect into. We never want that. We never want that. So, of course, we overlap it again. We have our membrane, goes over that IMP. We have another nice little flashing bit there, and then another membrane that covers over the top, really being redundant with making sure that no water infiltration is happening into that envelope. Pretty fun little detail. People get, pretty confused about how that works. It gets a little complex when we start introducing gutters, but if you have questions about that, let me know. We can talk about it offline. When we meet the base, right? Spanning, it's just steel insulation steel. There's not much of a section detail between the roof and the base, but when we get to the base, we have a few conditions to consider. When we meet the slab, we have kind of two methodologies that we can use. The first one, we have additional steps we'll talk about in the next slide, but if we're doing bypass framing, right, that IMP is going to go past that slab base there. We have conditions where we have extrusions that can accept that first channel of IMPs. This is very typical, keeps everything dry, keeps everything from sinking up underneath into the building itself. Additionally, if we want more of a flush condition where the IMP is lining itself up with the slab as well, we have some nice space. We have some silicone in there to make sure that we're nice and airtight. Then, of course, flashing and lip. Pretty standard stuff. But again, if you're confused about that, we can get into it at a later date. No big deal. Strictly speaking on that bypass framing, here we can see a situation in isometric form where we have some bypass framing occurring, and then it's obviously going past the finished floor. So again, there's kind of two methods to accomplish this shown here. The main thing we want to point to, though, honestly, is the fact that mineral fiber is going to be used to fill the gaps between the backside of these panels and itself to again maintain that thermal continuity. So we have bypassing IMP down to the structure as it meets that lip. We want to make sure that we have some mineral fiber back there too, so we're not getting some airflow at that base. Now, how IMPs deal with air infiltration? We mentioned it at the beginning, air and vapor, but the kind of secret sauce to IMPs, you can't make a building airtight just by having metal screwed to metal, right? The glue that goes in between those two um, the installation of that glue needs to be adhered to very strictly, and forgive the pun, but the ability for IMPs to ward off vapor and air infiltration is accomplished primarily on the market by what we call a non-skinning butyl. Essentially, what this is, and you'll see it here glued all over that structure, it's like a silicone that never quite gets dry. And what that does is, unlike the caulking you use around your bathtub that eventually peels up, this stuff stays wet for the duration of the building, meaning that it can allow for a little bit of movement and still keep that air sealant nice and tight. We do two lines of that. And you'll see at all the really important points we need to see that caulking occur. We're going over back gaskets to keep the system from being compromised laterally. We're going on the back side of the panels where it's making contact with that structure, again, to being really redundant to make sure that everything is locked tight and going to be lasting the test of time. This transitions us into case studies. I'm going a little long, so we'll go a little quickly through these. We already looked through this project. This is the Chase Stadium now, formerly the Auto Nation something stadium, formerly the David Beckham Soccer Stadium. It's changed a lot of hands, but luckily for us, it has never changed facades, which we like to see. Obviously, this is a building that has a lot of color that it's celebrating here. The other thing I want us to note about this that's very important for some of our applications, specifically down in the southern part of the United States, is you'll notice that this project is in good old Miami, Florida, right? If any of you have ever had the, uh, I don't want to say audacity, because I'm not a big fan of Florida, but the pleasure of being in Florida, you'll know that it is a hot, crazy humid place, and it's also very hurricane prone. So, with these panels being there and an exposed system, you'll understandably be like, well, how do they stack up against those extreme elements? They stack up very well. They work in every single climate zone, as I mentioned, and they are also Miami-Dade certified. Most manufacturers have that certification. For those of us who don't know what Miami-Dade certification is, it's essentially we set up our system, launch missiles at it, and then we do an air and water test. We pass. So IMPs are very robust and deal with this quite frequently. So just know that that durability is there. Another fun little case study here. Gilbert Place at Virginia Tech. Another fun project you'd walk by and you'd be like, that is not IMPs. It couldn't be. Totally, totally is. And luckily, the architect did a really good job with this controversial project because it was so large. It seemed like a mothership had landed on campus. Nobody wanted it around, but because we were able to introduce the IMPs, creating that nice, consistent rain barrier behind there, we were able to kind of mass out different parts of the building so that it looks like little chunks. And this does a good job of communicating the intent of what's happening inside the building, but also breaks up the kind of visual mass of how truly large this building is while still keeping the energy performance in front of mind. So we have some brick down here, some extruded plank, some, wood finished metal panel, whatever it is, and some exposed IMPs at top. All that stuff can be done without having to rely on one system. We can still have that nice thermal continuity, get our interior started 50% quicker, and still get something looking like this at the end of the day. Really cool looking design. Oh man, I have 3 good shots of this. Look at me go. Great project. Jones Hill House, no relation to me. Thank you for asking. Great utilization of a hybrid approach. This is out in Maryland, I believe. College Park, yeah. Great use of using IMPs both in as an exposed system as well as a backup system, right? We're still getting some really cool geometry, some really cool aesthetics with this particular building. But again, we're seeing performance, form and function perform congruently together. Even with these large facades, again, we can see with these higher ed projects that we are communicating what's going on inside. We're seeing some projections, some massing, some spaces, using that materiality, using that color, using these systems and all the tools in our toolbox in order to get this thing done and off the ground. Now, often when we're talking about IMPs, we're talking about speed of construction. This is the last case study I have to share with you guys. Uh, Whenever we're talking about speed of construction, the second question I get is how can you make it quicker? Well, prefab is also an option. The answer is if you are down to clown, so are we. We sell directly to installers, and if they can take the panels and pre-install them, we can do it. This is an example of just that, right? New Hilton Tower Convention Center in downtown Columbus, Ohio. You can see here these trim pieces. And what we have is maybe 5 IMPs stuck together in once. This is a lot of vertical circulation area that we need to cover up in a high area. And so we don't want a bunch of guys doing a high rope course up there. So we want to install quickly and we want to install responsibly. So this is what we do. We attach those panels off-site at a facility. We ship them in, we crane them up, we attach them from the inside. They're good to go. Another good example of being used in an urban setting, especially when there's zero lot lines, because these panels stack on top of each other and can be installed from the inside. Very good for systems and projects where they're up against another building in particular. So, conclusions. We've seen how IMPs can be used in order to make buildings healthy, comfortable, safe, and performing incredibly well. We also saw how we can use exposed IMP systems and other strategies to communicate shapes, patterns, forms, textures, and honestly just create really cool, interesting buildings. It's a very case study heavy presentation, so I hope you guys walked away a little bit inspired. We certainly looked at different applications. We looked at different details on how we actually put these things together. And not only that, we looked out for some of the kind of roadblocks as far as getting these things specified and specified correctly. We want to make sure that we're doing everything we possibly can to make sure our buildings are not only doing what we intend them to do, but also perform well. So IMPs, again, whether you fall into that form over function or function over form, we want to have your back, and that's what we want to do. So with that being said, I went through that a little quickly. I appreciate everybody. I am going to be wrapping things up. Thank you again for everybody, especially at Acelabs. My contact information is here. Otherwise, I'm going to kick it back to Elise, and we can be opening up for discussion and questions. So I think we have a little bit of time left, right?
Yeah, we'll push over 2 or 3 minutes just to ask two
Okay.
or three of the questions here. Also, I went to Virginia Tech Architecture School. Didn't realize you guys did
There
that.
you go.
That's
There
cool.
you go.
That's awesome. Okay. real quick here. We're gonna rapid fire through a few of these if that
Sure.
works with you, Dakota.
Okay.
Do IMP qualify as continuous insulation as required by IECC thermal requirements?
Oh, that is such a fun one. And no short answer, unfortunately. The shortest
That's
answer
okay.
I could give you is no. Unfortunately, they do not. It drives me up a wall because we have literal insulation on insulation connection, but technically, no.
That's okay. If you want to take a few more minutes to answer, that's totally
Oh,
fine.
it's fine. If they want to email me, I can send them all kinds of stuff about that.
Okay, perfect. Next one, I would like more joint detailing information and options. Blah, 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 blah. Oh, I've got our email, so I'll put you guys in communication with each other here.
That'd be great. Yeah. I honestly wish the whole presentation was joint emails or joint details.
Yeah, I'll after this, Patricia, I'll put you into email communication with Dakota, so you guys will be able to get that right there. About fire performance, can you clarify which of your systems have passed NFPA 285 testing? What were the specific assembly configurations?
Yeah. So this is another person to answer your question very directly. I'd be happy to talk with you more off the line. I have a whole chart with approved products that we can use via Intertech. It's all third-party verified. For those of us who are less aware of what NFPA 285 is a test of, it's an assemblies fire test. It kicks on when we're doing rain screens. The We call it a carrier panel. That is the rain screen panel that we were talking about. It's essentially an IMP with an integrated hat channel. That's where the NFPA 285 is going to be. So look up carrier panel. That's where it's going to kick on. And that we have certifications through pretty standard materials, your plate, your thin brick, that kind of stuff. And we can follow up with that too. But we have those bases covered.
Perfect. Okay, let me pull up one more here. Sorry, I'm going through a few of them. Give me just a second. Okay, one that came in through the chat here.
Hmm.
Um, what are the critical installation tolerances I need to coordinate with the structural framing contractor?
Whoa, that sounds like a very project specific question, and I admire the
I'm
specificness of it, but I would need way more way more information to make sure I don't just spew a bunch of stuff. You don't, it's not to make that person feel bad or whatever, but I might need a little bit more context to answer that one. So please email me. I'd be more than happy to help.
okay. This one seems to be a little less specific, so this might be a good one for us to end on too.
Okay.
What's your shop drawing turnaround time and how detailed are they typically?
So shop drawings. It varies a little bit. We're kind of in the crunch time of the year right now. Typically, what we say, depending on when you guys need panels, there's not a set number. I hate to dance around this, but Kingspan in particular, we are the largest because we are the most motivated. We can get you guys your panels very quickly, and we can have our shop drawings turned around very quickly, depending on what your guys' needs are. So my question back to them would be, when do you need them? Because we can get it done quick. We can also take our standard time. It could be 10 weeks, it could be a few weeks. It just depends. So again, email me. I can get you specifics. It just varies too much. I don't want to tell you something that's inaccurate.
Okay, well, I think that's all we have time for. But again, everyone has his email, and I'll be putting people into contact with Dakota personally so that you can get all your questions answered as well. Thank you so much
Excellent.
for your time and a super interesting presentation.
Thank you so much. I really appreciate it. And thank you everybody for attending.
Bye, everyone. Have a good Thursday. Talk to you later.
Bye.